We present PEGASUS personalized generative 3D avatars with composable attributes. PEGASUS is a method for constructing personalized generative 3D face avatars from monocular video sources. Our model, PEGASUS, enables disentangled controls to selectively alter the facial attributes of the target individual while preserving the identity. Here we show a demo of our model, PEGASUS. We introduce a pipeline of PEGASUS. Our goal is to build a personalized generative 3D avatar from monocular video inputs. Firstly, we introduce how to train avatars from attribute DB videos. Secondly, we present the method of generating a synthetic DB using avatar from attribute DB videos. Lastly, we introduce how to train PEGASUS using the synthetic DB. We create deformable avatar models from the attribute DB videos, which are monocular RGB inputs. We collect 109 publicly available videos from the internet and build an avatar for each. Here we show some examples of our collection of avatars from attribute DB videos. Next, we introduce how to generate a synthetic DB. First, we deform the avatar from attribute DB videos to fit the shape of the target identity using flame shape parameters. Then, we align the avatar with the target identity using flame expression and pose parameters. After rendering the attribute from the aligned avatar, we perform segmentation of facial attributes using an off-the-shelf network. Finally, we synthesize a segmented attribute image with the original video, which is a target identity. These videos are some examples of the synthetic DB created through part swapping. For small facial attributes, we indicate them with arrows. Our synthetic DB includes a variety of hair, hats, eyes, noses, mouth, and eyebrows. We introduce a method of training PEGASUS using the synthetic DB. We demonstrate through this example how the latent code, which is one of the main inputs of PEGASUS, is configured. The input latent code is designed to include everything except the target person's hair latent code. Also, the input latent code includes the hair latent code from the generated synthetic DB. As shown in the right image, we configure the latent code in the approach that PEGASUS is encouraged to learn only the changes in hair compared to the original target person. We show the method of configuring the latent code for the nose. The main inputs of PEGASUS include a latent code that reflects the characteristics of the synthetic DB and a generic canonical point cloud. Our method, PEGASUS, outputs RGB, normals, and segment cues in the deformed space from the generic canonical point cloud and latent code. We leverage RGB, normal, and segment loss to ensure that PEGASUS achieves high-quality appearance and accurate segmentation. We present the results of our synthesis method and PEGASUS. Additionally, we show applications leveraging PEGASUS. PEGASUS creates an avatar with a facial attribute within a single model. We show the rendered appearances of avatars with novel expressions and poses. PEGASUS is capable of synthesizing multiple facial attributes. Note that there are no instances in the synthetic DB where more than 2 facial attributes are synthesized simultaneously. In the examples, we are showing deformable avatars possessing two facial attributes at the same time. Next, we present another method that allows for the creation of personalized generative avatars without generating a synthetic DB. First, for a given new identity video, we create the avatar of the new identity using our PEGASUS network architecture. Additionally, we use the segment cues of the pre-trained PEGASUS from the synthetic DB to select the point cloud of the desired facial attribute. We refer to the method of representing both point clouds simultaneously in the deformed space as zero-shot transfer. We show the rendered image sequences of an avatar created by naturally synthesizing a novel target human with a hair from the pre-trained PEGASUS through zero-shot transfer. We perform interpolation on hair using a zero-shot approach through the latent code interpolation of PEGASUS. We compare our method with the baseline. Our synthetic DB generation method shows that the target identity is best preserved compared to other baselines. Also, we show that the original attribute is most accurately transferred and naturally synthesized. We compare the generative performance of PEGASUS. Our latent code configuration and synthetic DB generation show compelling generative performance in latent interpolation and swapping compared to other baselines. Thank you for watching.